So here we are at our third and final method of how to solve a system of equations. I feel as though this is the easiest and quickest way. I like this method the best, but each method has its own benefits, and you'll start noticing when to use one over the other. But the elimination method is exactly what it sounds like. So it's where I solve systems by adding equations to eliminate a specific variable. Now, what you have to understand is the variables you're going to eliminate, they have to have opposite coefficients. So like the opposite of 5 is negative 5, okay? So how do we do this? Well, step one, we have to make sure the equations are lined up. So if x is on the left side of one, x has to be on the left side of the other. If y is on the left, y has to be on the left. They have to be on the same side of the equal sign, and they have to be lined up. Step two, okay, we are going to add the equations to eliminate the variable with common. Now, it says common, but I want you to write opposite coefficients, okay? So cross out common and write opposite. Now, I also want you to add this note. You might have to multiply one or both equations to generate an equivalent equation that has the opposite coefficient. Don't freak out. We're going to show you what this looks like. We're going to have plenty of practice in it. Okay? But once you've added the two equations together, you're going to solve with the remaining variable. After you found that, you're going to substitute it back into the original, not the changed one, and solve for the other. Okay. So our first step is to make sure that they are lined up. So if we take a look, my y's are both to the left and on top of each other. My x's are both to the right and lined up, one on top of the other. And then even though this is kind of a diagonal, they're lined up. They're in the same position, okay? So now that we have that, we are going to look, and I'm going to eliminate the x's. That's just my choice. So since the first equation has 3 and the other one has 1 as coefficients, they are not opposite yet. Okay, they're not the same. I'm going to multiply the bottom equation by negative 3. Why negative 3? Well, the whole point is that I create an equal equation, an equivalent equation, where the coefficient of x is the opposite of the other one. So since my first equation was a positive 3x, if I multiply everything on the bottom by a negative 3, I now have opposite coefficients. So let's go see what that looks like. So I'm going to take the bottom equation. If I multiply one thing, I must multiply everything. So I distribute that negative 3, I get negative 3y. I also distribute it to the x, I get negative 3x. Remember, that was my goal. And then I give it to the negative 2 and get positive 6. So now this is an equivalent equation. I can take, okay, my original and my new equation I just created. Now that I have opposite coefficients, I am able to add these two together. Okay, so now I'm going to add them. If I add y and negative 3y, I get negative 2y. And then I add 3x and negative 3x, I get 0. And then I add 4 and 6, I get 10. Remember, ladies and gentlemen, my whole point was to cancel the 2x's out. And I did that, okay? We don't write 0x. That's just an unnecessary, it's just a placeholder. I don't put it, okay? So really what you get is negative 2y equals 10. Well, now you're able to solve. You divide both sides by negative 2. so that y equals -5. But remember, you're not done. Go plug that value back in to one of the original equations. I'm going to pick this one because for me it's easier. So I replace I replace y with -5. Add 2 to both sides so that I get x equals -3. Therefore, the solution to this problem is -3, -5. Okay, let's go try another one. So the thing I like about elimination is you don't have to solve. You don't have to isolate a variable. You just have to make sure they're lined up. So in this case, they are. Okay, my x's are with my x's, my y's with my y's, and then my constant with my constant. But if you take a look at the coefficients, none of them are the same. Well, they are the same actually. The x's both have a 1, but do I want them to be the same? No, I want them to be opposite coefficients. So I'm going to just take my bottom equation and times everything by -1. That gives me -x plus y equals -3. So I have a new equivalent equation. I can then take the original one and my new one and add them. Because watch what happens. My x's cancel out, my y's become 5, and my constants become 10. Remember, 0x, we don't write it, so it's really just 5y equals 10. I divide both sides by 5 to get y equals 2. But I'm not done. I'm going to plug it back in. I'm going to pick this equation because I want to show you it doesn't matter which one you pick, but we always go back to the original problem. So I'm going to replace y with 2. So I get x plus 8. I subtract 8 from both sides so that x equals 5. So you have your y, you have your x, but that's not the answer. This is the answer. Your answer is an ordered pair. So we want you to try this one on your own, okay? We're going to be looking, we want you to do it by the elimination method. Okay, so be careful here, because if you notice, we jump from question 3 to question 11. So make sure that you are doing this problem and this problem only, that they match. So everything's lined up. Now the dilemma is everything's identical here, but we want opposites. So it doesn't matter which one. I'm just going to take this equation and I'm going to multiply it by a negative. I can do that. It's like times a -1. Because what happens is I now have -3x plus 4y equals a positive 10. And then I'm going to add to it the other original equation. When I do this, what happens is I get 0x, 0y, but I get -3. So does 0 equal -3? Will it ever equal -3? No. So it's no solution. Remember, this doesn't change. If the variables cancel and the two sides are not equal, it's no solution. So let's look at this one. Now this one's actually a little easier. Why is this one easier? Well, if you look at the coefficients, they're already opposites. So all I'm going to do is I'm going to take my first equation and my second equation. When I add them, I get 0x minus 0y equals 0. Does 0 equal 0? The answer is yes. It will always equal 0. Therefore, it's infinitely many, meaning the same reason. When the variables cancel and the two sides are equal, it's infinitely many. So ladies and gentlemen, we've thrown at you a lot in a short period of time. You need to ask for help in class. Don't just sit there and think that it's magically going to finish itself. please ask. That's why we're here.